Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Carlos, welcome to the program.
Thank you for having me here.
This is going to be a fascinating discussion. When I was over at Wind Europe, the activity around your booth was really good. A lot of interested people wanting to learn more about the technology and how to protect their blades and be able to determine early if they have blade problems. And I think everybody on the podcast knows that blades are a huge issue financially, and we just don't have enough information about how they are moving structurally or what kind of structural issues they're having. How big do you think this problem is, Carlos?
I agree with you. So we had quite a busy Wind Europe event. We were really full all the time. And I think that the problem is really getting out, right? It's like every year, more than $5-6 billion are being spent in non-planned repairs activities. And this is impacting a lot to the bottom line of the industry. So what we knew at Fibersail 3, 4, 5 years ago, that the problem was really big on the blades. Now it's mainstream knowledge. Big companies are putting billions of euros in recognized losses because of this issue. And more customers are coming to us. So it's really a big issue, and we believe that it can really put in danger the wind industry as a whole.
Yeah, and even if you buy a new turbine today, there is very little information that comes from the blades themselves. A lot of it is coming from the SCADA system. And those SCADA systems are not designed to detect the sort of issues that Fibersail can detect, correct?
Yeah, and I think it's like, we are building bigger and bigger blades using old technology, right? It does not work. You have a mixture for a big explosion happening, and that's exactly what we are seeing. If in the past, the turbines, they were showing problems after 5, 6, 7, 8 years of operation, today we have customers that come to us with big problems in blades after 1, 2 years of operation. Some of them still during the warranty period. So it's really becoming a big issue. And that's where our shape sensing technology kicks in, because we have advanced sensing technology for the most advanced turbines out there. And the new ones, it's really good in theory, but the reality is a different story.
Well, how soon should you install a system onto a blade, particularly a new blade? Should it go in at the factory or immediately after in the warranty period? Or a lot of operators that we have seen like to install them at year 5 or 6 of operation, which seems late to us.
I tend to agree. We would prefer to have it installed at the manufacturing. We know it's not straightforward. And so what we're doing, and this is, let's say, our go-to-market strategy, we are working with end customers, the owner-operators of the turbines, the ones that have the hurdle, they have the problem to solve, and we are working with many of them. We are deploying, we are doing a retrofit installation, and that data then can be used to convince the OEMs to integrate this technology. Of course, that's our end goal. We understand it will take a bit of time, transparency, the level of transparency we bring with our shape sensing technology. Sometimes people try to avoid it at the beginning, but we want really to use the data from the field and the value that we deliver to our customers to push this into the product. So hopefully the next blade that the customers are buying from the OEMs will have Fibersail technology inside it.
So let me ask you a little bit of a question about that, kind of how it fits into the marketplace, because we're going to get into the amazing technology that you guys have. But I just want to understand, because, when we talk to operators, a lot of times they're like, hey, I'd love to implement this solution, but hey, I can't do this until end of warranty, or I'm under a full service agreement for the next 5 or 10 years, or whatever that may be. And the OEM doesn't want to allow me to put this CMS on, or this aftermarket product, or these things. And contractually, those contracts can be pretty tight, where you can't even put stuff on that's even air gapped. How have you guys dealt with that, or have you ran into those hurdles yet?
Yeah, definitely we have. There are different kinds of customers, of course. If there is no contract trying to block anything like this, we have an easy entry. And we have some customers like that. Others, they really fall into what you said. Some of them even during the warranty period. So we at Fibersail, our position here, we are a solutions provider, and we position ourselves as a solutions provider for the industry, not necessarily for one or the other side of the industry. So we don't want to be used as a source of information for one side of the industry to try to attack the other side. We really see that the industry has an issue, and we want to provide transparency to avoid costs and to make wind a competitive source of energy. And so in those situations, usually we try to do a cooperation with three parties. So Fibersail, the end customer, and the OEM if possible. So we always try to invite them to the table if possible, because, you know, we have cases where actually the contract is blocking the entry of a sensing technology like ours, but the customer is losing above the cap of compensation from the OEM. So they are losing lost production. So the problem is really big. So there needs to be found a solution. And at the same time, the OEM is losing money because they are paying the compensation, okay, till the cap, but they are paying a lot of money. And they will need to pay this for 20 plus years. So we position ourselves as a solution provider on both ends. Of course, it's not easy, but as I usually said here with the team, if it was easy, it was already done. So we are in the tough stuff.
Well, let's talk about the technology just for a moment. It's obviously Fibersail. The technology is in the name. It's fiber. But I want to understand a little bit about how you're using the fiber, how it's installed, where does it go, what is the electronics or the electrical boxes that are connected to it. What does the system look like?
Well, as you said, fiber, it's easy. The sail part, I can do here a connection, right? Fibersail started measuring the shape of the sails of the sailboat. And now what we are doing is applying the technology to a different sail, right? A blade is a rigid sail, and what we are doing is really to get the added level of information of how that sail is behaving in real time. And so what we build actually is our shape sensing technology. That's the unique approach. We built a fiber optics beam that we glue inside the blade. We go from the root till where we can install in the retrofit. Of course, when we do the integration in the product, in the end, we can go all the way to the tip, but that's a possibility for a later stage. And basically, we encapsulate all the fiber optics, all the technology that does require more detailed level of expertise from the people in the field. We encapsulate everything into a system, and then we hand over the system to a normal field technician that can simply glue our sensor to the blade, plug the power, and then we are working.
Wow. Okay. And how many pieces of fiber would typically go in a blade? Is it a bundle of fibers in one specific area, or is it spread out across the blade structure?
We have two products today. We are working on the next two. They are still not at commercial level, but basically we have our shade sensor. That's our core technology, but we also have, for example, in our product line, the standard load sensors. It will be incredible to know that more and more customers also need this kind of data. You know, even basic load sensing data is not available for the end customer, and we can provide it. And so the setup really depends on what the customer wants. So if the customer just wants very limited information, for example, we can provide a system with the load sensors in it. If the customer wants, for example, early damage detection, we put our shape sensor in it, and we actually add on top hotspot sensors to do really the early damage detection. So it really depends on what the customer needs. What we do, we call it internally tailor-made, but at scale. It's that we adjust and we make a system using all the resources we have in our product line to offer the customer a solution that works. And then it works for that turbine type, for that customer. So to give you an example, we are working in a package that will be really working on early damage detection for a specific turbine type in the field that has huge damage issues, and then we have a system that works for the entire fleet of that turbine type.
So one of the things I want to just touch on there, and you briefly mentioned it, and it's implementation, right? So we want to, I'll raise a hand. I'll put my operator hat on. I want to retrofit the system in the field. Okay. Because that's going to be a lot of what it is. It's going to be less right now, of course, factory installs and more after the fact. So if they're going to put it in, you guys have packaged this thing so it's easy for technicians to install. So you said like basically it comes in, they'll be in different, like a beam of sorts, and then it's clean and go inside the blade, clean, epoxy, stick it down and plug it in?
More or less. It's not as easy. What we did, and we can do the installation ourselves, and usually we are doing the installation of ourselves for the initial qualification projects we do with customers. Let's say you want to test our technology, let's install in 5 or 10 turbines. We can do it ourselves, and then we go to the hundreds of turbines that you have in that model. And then we usually go to a service company, actually the ones that do the service of those turbines in the field. And for that, we do a training session. And so we train those teams to do the installation for us. But we can do this because we put all the complexity parts on our side, all the fiber optics connected part with our side. And then it's a robust system. It's out there. You can put your feet on top of it. You can try to destroy it. It will not get destroyed so easily. And then you send it to blade technicians, and they can do the installation themselves, following, of course, our protocol. And we do the quality assurance on our side.
So, Carlos, once the system is installed, what are we looking at as a data stream? Is there a data stream that goes to the cloud? Does Fibersail analyze that data, or is it data that the operator can analyze? What does that interface look like?
We have all the data flow prepared from the sensor itself, sending the data through 4G, 5G, Starlink, you name it, to the cloud. And then we have even a dashboard solution for the customer. Anywhere in this process, we can say that we don't go all the way. For example, we have customers that they don't want our dashboards because they do have dashboards. And actually what they want is that we feed our results into their dashboard. So we can adjust those parts to what are the needs of the customer. But we can do the full sweep in terms of the data flow.
Okay, so this is an important thing too, because we're talking about implementation here. We've heard this from many operators. We hear from other CMS companies. Cybersecurity is a big issue, right? Because people want to make sure that, no nefarious activity could happen within the wind turbine or anything like that. So how are you guys handling cybersecurity?
Yeah, we take it very seriously. Of course, all these communication protocols, they are to the highest standards used in the industry. So we take them very, very seriously. And in some cases, I'll say mostly with the manufacturers, we actually do an edge solution, meaning we collect everything on the turbine and we don't use any cloud access, any connection outside of it. So we use it, we store it there, and then we communicate directly even to the data lakes of the customer if need be. So we have these two levels of options, let's say.
Okay, that makes a lot of sense. And then the interface is working with a large operator. Obviously, they have their own dashboard set up and they're watching the turbines and the structure. So there's an API then that takes your data and pumps it into their specific system? Is that how that works?
Well, I'm not the technology officer here, but to give you an overview of that, it's like we don't offer the customers the raw data from our sensors. We offer them already the output, the value. And then we can stream them to their own dashboard. We have customers that, for example, they tell us, I don't have time to go through a dashboard and look into beautiful graphs and data. What I want is to receive an email if you spot a problem or a potential damage that's propagating. I want to receive an email to go and look into that. And then our dashboard is actually an email or 2 emails that it receives when our system detects something is off.
I think that, to be honest with you, that's more and more of the direction that the industry is going, and it's driven by the feedback from the market. So kudos to that, doing your primary market research there, because these engineers and site supervisors and asset managers, they have so much going on that at the end of the day, they just basically want to be told what to do. They don't want to analyze the data. They just want to see that you've installed the solution. It's doing its smarts. You guys are analyzing the data yourselves, and of course probably using some algorithms and whatnot. And they just get that email. They just get that notification. Go look at this turbine, or hey, you've got this propagating. Check this out. that's the way things need to be done.
Exactly. And if you think about what we see is that you have a handful of people taking care of gigawatts of turbines out there. And then all of them have issues, but some of them, they need to be repaired this week. Some of them, they can wait a couple of months to do it. Today, you don't know how to do it. So what you do, you send teams all the way every month to check every single turbine. And what we believe at Fibersail is that to start, you don't have the manpower to do it, and then it's not smart to do it like that. So the more complex turbines, they will get a warning from Fibersail, and that's the ones you need to pay attention to. Because the other ones, they do have problems, but it's not a damage that will hit you next week. It will continue to propagate, and you can optimize the way you manage your fleet.
Well, that's a real interesting point. So Fibersail's data stream, which is really accurate, can then predict the damage curve in a sense, or how damage will progress based upon your intimate knowledge of that structure and when it is actually happening. That's really valuable.
Yeah, and we do it in a different way from the industry. We have other technologies like vibration sensors, slow meters, and other stuff. What we have that's unique is that we get the shape of the blade in real time. And so we look into the variations of the shape, but also we look into the model analysis of that structure, right? The frequency of that structure. And so we do a kind of a double validation. So if the shape changes and the frequency also changes, we have two variables to check that the problem is really there. So, and I don't see any other technology out there doing this double validation to avoid false positives, right? So it's like we have much more confidence in the result that we are providing to the customer.
So the different vibration modes that will happen on a blade, they do slightly alter over time as the blades age. Is there a significant variation there, even between blade to blade made in the same factory? Are you seeing variations in the sort of the overall performance, the way that the blade operates or moves based upon just the variations in manufacturing?
Well, definitely yes. Let's say the blades are all the same when they leave the factory. That's only theory. That's why you only have a numerical model to try and simulate that. The reality is that they are all different from the factory, from the manufacturing tolerances. And then just think about 1, 2, or 3 years of operation, a repair, a new patch of fiber, and then you have a Frankenstein turbine in your hands that you don't know what's doing. And that's the reality we have today. So all the numerical models, everything you have, they are really far off to give you the precise knowledge about that.
I think the industry would really love to see like a white paper or report of some sort of here's what Fibersail was able to sense in basically a virgin blade, and then this is what it looks like after this repair and that repair. Because like big scarf repairs, they're designed to not create structural load hotspots, but I mean, there's no way to get that perfect, right? So I would love to see, because I know like there's been a couple of DTU masters projects kind of about this, but it's all been FEA stuff. It's all modeled. It's not actually sensed, and it would be really interesting to see if you guys could do that.
Well, what I can tell you is that we have a bunch of projects out there. We are collecting data as we speak. Some of them, I will say, actually a very promising one in the next couple of weeks, really targeting damage detection, early damage detection and damage propagation. But it's as said, nothing is valued as the data from the field. So we are collecting the data. We are working on that. Actually, we did some publications at Wind Europe. So what I can tell you is that stay tuned because we'll be launching some cool stuff in the next months.
So where's the emphasis at the moment? Is it onshore wind? Is it offshore wind? I can see the value in offshore wind in particular because the loss of like a 15 megawatt turbine is a big driver. It's a huge money issue. Where are you seeing the most activity for your systems?
Well, we are starting onshore. It's always an easier entry, let's say, and also the volume is there, much higher volume and a lot of problems. We are doing this summer the first offshore installation in the Netherlands, and all the indications we have is that we have no issue going offshore. It's just a matter of planning the installation, doing that, and then the return on investment will be even greater. But again, we are working to have that business case proven with real data in the next couple of months. So let's see if you can get it, right? To put the data on the table.
So what is the feedback from your customers today? What are they saying?
We have different kinds of customers, as said. Some customers just want basic data. Others, they want really the high-end system that you can offer also. So we serve all of them because our systems are built in a modular approach, so you can add layers of complexity as you need, basically. But I think the most interesting feedback we got, because is using everything we have in our product line, is that he tried every other technology in the field and none of them can help them. And then he said, but what you have is something different. I really want to see if you can help me because I don't know what to do. And that's a great feedback for us, right? As I said, we like the tough stuff, easy stuff, everyone can do it. We are focusing on the really hard stuff because after we solve the hard stuff, we can also do the easy stuff. It's like after we detect the damage, we can do AP increase. We can do whatever you want. It's a no-brainer for us after we can do the early damage detection.
So the system sounds fascinating, and I do think there's a place for this today. And we don't know much about these larger blades, and we're trying to learn as quickly as we can, but one of the things that Joel and I talk about all the time is just a lack of data. If you don't have any data, it's hard to do engineering, and it makes it hard for the next generation of blades to be better. So Fibersail is going to change that dynamic quite a bit. And if you want to talk to Fibersail or reach out to Fibersail, Carlos, how do they get a hold of you? Where do they go?
Well, we are quite active in the industry events. That's a good start, but our webpage is always there with, you can contact us directly and we'll follow up on that, be assured. Or follow us on LinkedIn. We are also sharing there some insights of what we do. Come and talk with us. We will love to try and help you on that.
And the website is fibersail.com, Fibersail.com. Great information on the website, Carlos. It's full of good information. So if you're trying to quickly learn what Fibersail does, just check out the website. And yes, the LinkedIn page that you have is really good also. So a ton of information for everybody to go check out and learn from. Carlos, thank you so much for being on the program. Really enjoyed the discussion.
Thank you for having me.